In this lesson, we will explore economic order quantity, or EOQ, and lot sizing models, two foundational concepts in inventory management that help organizations minimize costs while ensuring product availability. These models guide how much to order and when to order, balancing the trade-off between ordering costs and carrying costs. Let's start with the economic order quantity model. EOQ determines the optimal order size that minimizes the total cost of inventory. The model assumes that demand is constant, lead time is fixed, and each new order is received instantly when inventory reaches zero. The goal is to find the quantity that minimizes the sum of two key costs: ordering costs and carrying costs. Ordering costs are the expenses incurred each time an order is placed, including administrative work, transportation, and supplier communication. Carrying costs, on the other hand, are the costs of holding inventory, such as storage, insurance, depreciation, and the opportunity cost of capital. When order quantities are small, companies place more orders and increase ordering costs. When order quantities are large, carrying costs rise because of excess stock. EOQ helps find the sweet spot where total costs are lowest. The classic EOQ formula is EOQ equals the square root of 2 times D times S divided by H, where D represents annual demand, S is the cost per order, and H is the annual holding cost per unit. This formula provides a straightforward way to calculate the optimal order quantity. For example, if a company sells 10,000 units annually with an ordering cost of $50 per order and a holding cost of $2 per unit per year, the EOQ would be 707 units. This means the company should order 707 units each time to minimize total inventory costs. EOQ offers several advantages. It provides a clear guideline for inventory replenishment, reduces excess stock, and helps maintain consistent cash flow. However, its assumptions, such as constant demand and lead time, may not always hold true in dynamic business environments. Therefore, EOQ is often adjusted or expanded using more advanced models. This brings us to lot sizing models, which build upon EOQ principles to accommodate more complex, real-world conditions. Lot sizing refers to determining the optimal production or purchase quantity that minimizes total costs while meeting demand and operational constraints. One common extension is the economic production quantity, or EPQ model, used in manufacturing. Unlike EOQ, which assumes instant replenishment, EPQ assumes that inventory is produced gradually over time while demand continues. This model is useful when production and consumption occur simultaneously, such as in assembly lines or batch processes. Another variation is the dynamic lot sizing model, which accounts for fluctuating demand over multiple periods. Techniques like the Wagner-Whiten algorithm analyze demand patterns and adjust order quantities accordingly. This approach helps prevent overproduction and stockouts in industries with seasonal or irregular demand. Lot sizing models can also incorporate quantity discounts. In these cases, suppliers offer lower prices for larger order quantities. The model evaluates whether the savings from discounts outweigh the additional carrying costs, allowing businesses to make cost-effective decisions. Technology further enhances EOQ and lot sizing applications. Modern ERP systems can automatically calculate order quantities using real-time data on sales, inventory, and supplier performance. Advanced analytics and AI tools continuously refine these calculations to reflect changes in demand, lead time, and cost structures. As a result, inventory decisions become faster, smarter, and more responsive. In summary, economic order quantity and lot sizing models provide a scientific foundation for inventory decision-making. They balance cost efficiency with operational reliability, helping organizations maintain the right amount of stock without waste. While EOQ offers a simple and elegant solution for stable environments, lot sizing models expand its power to address variability and complexity. Mastering these tools enables businesses to optimize inventory, strengthen supply chain performance, and achieve sustainable profitability.